Welcome back, mathematicians. Today we are going to start talking about functions. We're going to talk about what a function is, how to make a function table, how to make a function rule. To get us started, we're going to learn some background information about hummingbirds. Enjoy this little video.
Hummingbirds. Animals on our planet come in all shapes and sizes, from the magnificent blue whale to the small and spectacular hummingbird. Sure, hummingbirds are adorable, but they're also fascinating. Measuring anywhere from 2 to 5 inches, this tiny creature is the smallest bird in the world. Besides their size, hummingbirds also have other interesting records in the animal world. Their heart beats at an incredible rate of 1,260 beats per minute. That's 21 beats every second and is the fastest of any animal. Compare that to the average adult human heart that beats around 80 beats per minute. They're also the only bird that can hover in one place and even fly backwards. What else can hummingbirds do? They take about 250 breaths per minute while at rest, fly an average of 25 to 30 miles per hour. And their bodies work so fast that they need to consume more than their own weight in nectar every single day. To do that, they'll need to visit hundreds of flowers. Do you know how to make a function table to find the number of times a hummingbird beats its wings for any number of seconds? Find out in this lesson.
Now that we know a little bit more about hummingbirds, we're going to take some of the data that we learned and we're going to learn how to use function tables. Now in the video, we must have been learning about a different hummingbird than the ruby-throated, because our fact here says that a ruby-throated hummingbird beats its wings about 52 beats per second, whereas in the video it said about 26, I think. But let's use this data and go ahead and check out what it means to make a function table. So first we need to make a table showing how many times this bird beats its wings in 2 seconds. So this first column here is our variable. That's the number of seconds. It can change. We could do 2 seconds, 10 seconds, 52 seconds, 837 seconds, 11 billion seconds, whatever we want. So this right here is our first variable. Here is our algebraic expression, which helps us figure out the rule. It is seconds times 52, however many seconds we choose, times 52. And then that'll get us our wing beats, or our output. If we did 2 times 52, we would discover that the ruby-throated hummingbird beats its wings 104 times. There is no need to be writing any of this in your notebooks right now. We are just watching along, and then we will take notes in our notebooks when it is time. Just like we could figure out how long it takes. Oh, my 104 is not going to stay there. Bummer. All right, we can also use other variables for S instead of just 2. We could make a table to show how many times the hummingbird beats its wings in 6 seconds. So our variable is 6 seconds now. We're going to plug it into the algebraic expression, S times 52. So we substitute 6 for S to get 6 times 52 to discover the wings per beats per 6 seconds. So if I do 57 times 6, 312 beats in 6 seconds. Make a table to show how many times it beats its wings in 20 seconds. That's fine. We know that seconds is our variable down here, so we're going to plug in 20. Substitute S for 20. Do 20 times 52. I'm going to use a basic pattern that I remember. If I have 1 0 in my question, I know I'm going to have 1 0 in my answer. Then I can just do 2 times 52, which I've already done above, which would be 104. So in 20 seconds, the hummingbird beats its wings 1,040 times. Uh-oh. Now, a giant hummingbird beats its wings about 10 times per second. Make a table to show how many times the giant hummingbird beats its wings in 3 seconds. So we're just going to organize the information from the word problem into a table format. Our first column here is going to be our variable. What changes? How many number of seconds we decide to use. That's going to be S. And in this case, we want to do 3 seconds. So I'm going to place 3 into the table. Next, I have my expression. Since the giant hummingbird does about 10 times per second. Remember, that's another word for each second, which is a keyword for multiplication. We know that it's going to be S times 10. So by substituting the 3 for the seconds, we can be more specific. 3 times 10, I know that would equal 30 beats. The giant hummingbird would do 30 wing beats in 3 seconds. Now that we've seen some function tables, let's spend some time in our math notebooks learning all the different vocabulary word that goes along with function tables. On your table of contents, we are going to call this function tables, and my page will be page 90. However, yours may be different depending on how long different sets of notes have taken you. So just find which note works for you, or which page is in your notebook, and write that down. Then turn to your next available page, and we're going to label it function tables. And let's talk about some vocabulary. First of all, what in the world is a function? A function is simply a relation that assigns exactly one output value to one input value. So in your notebooks, please write that a function is a relation that sets one output value to exactly one input value. If you think about this, it should make connections to your past when you did input and output tables. Also, our equations that we have been working on, there was only one value that the variable could equal to get the answer that we needed. So those equations could also be called functions. Next, we're going to talk about the function rule. The function rule describes the relationship between each input and output value. So if you think about our hummingbirds, our function rule was S times 52. And it describes our input value of S, our seconds, and our output would be 52 times as big as our input. And we could go backwards as well. If we had our output, we could figure out what our input was because of this relationship right here. So the function rule, also known as the algebraic expression or equation. Function tables, which we're going to be working with today, is simply how we organize our inputs and outputs and the rules. It's a nice tool to have to kind of see an overall view of what the function looks like, put the rules in, getting our inputs and outputs. If you have outputs and the rule, you can figure out an input because of the relationship. If you have the input and the rule, then you can figure out the output, just like we've been doing on all of our equations. So thinking back to our hummingbird example, if we drew the table that they set up for us, we would have our 3 columns here. The first one would have been number of seconds. This would have been known as our input, what number we inputted into the scenario. Then we had our s seconds times 52, which this is the function rule. It describes the relationship between this column and this column. Then we had our wing beats over here, which is also our output. What came out after we put in a number, applied the rule, we got exactly only one answer that could come back out. So when we put in 2 seconds into the input, and then we multiplied it times 52, the only number you can get out is 104 wing beats per second. To take this a little bit further, your input value is also going to be known as your independent variable, your IV. This number is called your independent variable because it can be any number you choose. You can pull out any amount of seconds out of the sky and apply it to this table and it will work. It is independent of anything else. Just like when you get older, you will be independent of your parents and you can make any decision that you choose. You don't have to ask them, you don't have to check on anything else. You'd make the decision. You are independent. The wing beats, or the output values, are known as dependent variables, or the DV. You might also have some connections to science when you're doing your science labs, and you have something that's independent of the changes you make, and then the output that is dependent on what you've just changed. The dependent variable relies on the input value. I can't make up any number that I want over here and just put it in. It relies on what happens on the independent variable. So this one relies on what I put in the input. When you are a child, you are dependent on your parents. You are known as a dependent because you rely on your parents to feed you and clothe you and keep a roof over your head. You can't just do that on your own. We will work more with identifying the independent variables and the dependent variables when we are looking at word problems. But just keep in the back of your mind as you are doing the functions tables today that our input values, any number that we want to put into the formula, is also known as the independent variable. The rule, the relationship that tells us how to get either one of the inputs or outputs, goes in the middle, and then our output value is dependent on the numbers that we plug into the rule. So it depends, what comes out depends on what number we have put in. Let's look at some other examples of function tables. I think you will find them to be easier than you expect, and you get to apply a lot of the knowledge that you have learned before. These practice problems will be on video 2, so when you finish with these notes, go ahead and open video 2.